Okay.
Hi, Ben. Hey, Ben is Parker.
Anyway, I'm going to deal with today's notes like we're drawing a line down the middle of the page for half of it. And we're going to keep that line going for a number of reasons because I want you, in a way, to think about the two families that we're going to have, two families of functions. And knowing what type of function it is going to be, of course, take your headphones out. Your other, both of them. No, we're not.
Hi, Ben.
The first one, the first family are linear, and the other family are radicals. So we need to know the difference between the two families in order to have the right kind. So I want you to think about the snowball that didn't happen on Saturday night. And think about, like, just for a second, pretend that you're deciding to go to the snowball. This used to be like the great dance before finals until we realized that we probably shouldn't be planning dances before finals. Anyway, you're going to snowball, and you want, for whatever reason, to go stag so you can be set up. And so you ask your friends, I want you to set me up with someone. Now, before that happens, before your friends can set you up with someone, there may perhaps be a question that they want to ask you. Because if you just say, please set me up with somebody, there perhaps might be some question, some little piece of information that they might want to know about you before they decide to set you up with someone. So this is very similar to this kind of thing, because before you go and solve these problems that we're about to do, you're going to have a mix, a flushing of two different types of problems, and you need to know what type to use and when. Whether it's linear, where you have maybe an x root 5, versus a radical, where you have a 5 root x. What is it that makes the second one a radical expression and the first one a linear expression?
There's a variable in the
Yes, if you kind of figure out what's the square root of 5, the first one is mostly equivalent to about 2.23x. Okay? And so it's linear. It's linear with an irrational x or coefficient, but it's still linear. If I graphed y is equal to root 5x, I'd get a graph that looks something like this. Up to over 2.3 over 1. I mean, look like that. If I graph y equals 5 root x, I get a graph that looks something like this. It's a curve. It's a very different type of graph than a linear one. And yes, while we keep this analogy going, the radical is not straight. Clever, Carson. So, going on. Let's start with the first type of equation. 2x root 5 equals 7. Actually, let's go equals negative 7, just for kicks. So 2x root 5 is equal to negative 7. What makes this be a linear equation is that you do not have a variable underneath the radical. So what I'm going to ask you to do is, after you copy the original problem down, see what I did there, underneath the equation, I want you to just put a single word, linear or radical, for this first assignment only. This is linear. Not just because it's linear on the left and radical on the right. See what I did there? Actually, I didn't do that period 5. Notice that. But no, the way that we're going to solve this linear is to do the same way that we've done with everything. Isolate the variable expression, divide by the coefficient. So what am I going to divide 2x root 5 by to get the x by itself? 2 root 5. In fact, the only reason that the x is sandwiched in between the 2 and the root 5 is just for a visual. The better way to write 2x root 5 is 2 root 5 in parentheses and then x, but it doesn't matter. You should see it both ways. And we're going to divide by 2 root 5, cancel the 2's, cancel the 5's. It's all multiplication division. There is no addition subtraction going on. So we know we can shuffle multiplication in any order and divide out things. It's all okay. And I get x is equal to negative 7 over 2 root 5. And somebody is going to circle that and put that as their final answer, and I'm going to have to take a point off. Because I don't just ask for solutions, I ask for simplified solutions. I also like set notation as the one first thing that I look at to see, did you even get the problem right? 7 root 5 over 10. Remember, if you know the value of root 5, about 2.23, dividing it by 10 and then multiplying it by 7 is not a terribly difficult piece of math to do to get an approximation, which is why this is preferred. So that is an example of a linear equation. Let's move to an example of a radical equation. 5 root x minus 2 equals negative 3. When I look at that, I see a variable underneath the radical. So I'm going to write the word radical. And because I'm writing the word radical, we now have to do a different kind of operation to solve it. Except we do know the first thing we're going to do anyway. Yeah, we might as well add the 2 to get 5 root x is equal to negative 1. Then, we can choose to divide both sides by the 5, but if you anticipate what's going to happen, sorry, I did that. When you divide by the 5, you're going to get a 1/5. And you have a fraction. That's fine, but if I square it now, if I go 5 root x to the second power equals negative 1 to the second power, this is now a new operation we're allowed to do both sides. I can square the left and square the right to get these things by itself. 5 squared is 25, root x squared is x, negative 1 squared is 1, and you get x is equal to 1/25. Yes, Mateo, you may. But 1/25, at the point we squared both sides, we ran into an issue where we may have extraneous solutions. I squared both sides. Squaring takes negatives and destroys them and makes them positives. That means that what was once equal may not be equal anymore. We have to check. And in the case of this, you must check with radical equations that you square both sides whether your solution is actually a viable one. So I do 5 times root 1/25 minus 2, and I'm checking to see, is that equal to negative 3? What's 5 times root 1/25? 1. And 1 minus 2 is equal to not negative 3. Now, it is close. That is important to me to check as well. I know that this is the right-wrong answer. What I mean by that is it's close because it didn't need to be 1. It really needed to be what? Negative 1. And that's okay. There was no way for it to be negative 1. That radical symbol means the positive. So it's like you can confidently put empty set, but you know that this was the right-wrong answer, and I am checking for every little bit, including the right-wrong answer. So don't feel bad if you get an empty set and say this was all completely pointless. I'm checking also that you got the right-wrong answers. And check the right-wrong answers. Unless you get this and see this right here and say, well, wait a minute. I see that I have 5, which is a positive number, times root x, which is also a positive number. How do I know root x is a positive number? Somebody, raise hand, tell me how I know root x is a positive number. Jack. Not close. We can't take the square root of negatives, but every number has 2 square roots. Going for a second reason here. Kendall.
It's an even root.
Even better. It's not necessarily that's even or odd, although it will affect it. There's one more reason, one more definition we gave very at the start. Herschel. Principal square root. The root, that symbol. This symbol means the principal, the primary, the positive. See me alliterate there. Square root. When you have even roots, even indices, 2s, 4s, 6s, 8s, this symbol means the positive one of them. It doesn't mean the negative one. If I want it to be the negative, I will put the negative. So that symbol by itself means it will be a positive number. So I have 5 times root x, positive times a positive. It cannot be a negative. And you can see it right there, which means if you put empty set there and see it, great. If you don't, keep going. Your work should show it. That is the key thing behind a radical function. A radical equation, I should say, not a function yet. So let's not draw it there. Let's draw it here. And no idea. Let's go 5x plus root 3 is equal to root 12. And underneath that, I'm going to write the word because this is a linear equation. There is no root x. And the first thing that I probably should do is actually just take a second and rewrite this as 5 plus root 3 equals. And when I subtract root 3 from both sides, you get 5x is equal to 2 root 3 minus 1 root 3 is. And when you divide both sides by the 5, you get x is equal to root 3 over 5. You did not square both sides at any time. You can check that when you plug it in, you get root 3 plus root 3 equals root 12, which is true. So we can put that in set notation and be done. Yes, Matt?
I'm just making sure we don't only have to check the radical ones.
Yes. You only really need to check the radicals because a linear equation will almost always have a single solution. And that's just a linear. If you think about a line, that solution is where the line crosses the x-axis. So how many times can a line cross the x-axis? Once. Just once. If it's cross infinity, it has a curve back. But a single line, just one line by itself, only cross once. There's going to be one solution. A radical equation can cross once. It can cross none. And as we're going to see in the future, it can cross more than once if there are two radicals in there. So let's do another one. Let's go 3x minus 5 root x is equal to 2. You guys have two methods to solve this. One of them you've already done, and the other one we're going to do right now. One of them, which I did not go over with period 5, is, and I'm going to write this in, but we're not going to use this one right now, is to let u be equal to root x. Remember that? So then u squared is equal to, and we make the whole thing a quadratic. And we can use the quadratic formula to solve it, which this would factor. But I'm going to hold off on that for now. And I'm going to take this and just kind of slightly shrink it and put it over here as an option. And we're going to decide what kind of equation this is. So what we're going to do is we're going to isolate. Isolate is a word that means get by itself. We're going to isolate the radical in order to square both sides. Despite the 57 puppies that were killed by period 5, you guys came in at a whopping 54, which is okay. You have more people than them, so the ratio is better. But yes, you guys did. We averaged about 2 puppy deaths per test. There were 4 opportunities for you to kill puppies on the test. And I bring this up because, guys, when you square both sides, you cannot just square everything. I'll hear that from people saying, let's just square everything. That's not a thing you can do. What I can do is get the radical over on the other side and get the 2 over here and make this 3x minus 2 is equal to 5 times the square root of x. That is isolating the radical in preparation for this next step. Raise the left side, raise the right side. How do you raise the left side? 9x squared. What's my next term? Plus 4. Don't forget the 12x. Equals 5 squared is 25. Root x squared is x. Subtract everything over to the left side, and I get 9x squared minus 37x plus 4 is equal to 0. This has been so artificially crafted so that it can factor pretty cleanly. Note how 37 is so close to 35, or 36. So 9x, x, 4, and 1. Make sure that I multiply the 9 and the 4 by to get 36. Minus, and you get x is equal to 1/9, or x is equal to 4. But, yeah, which ones? Both of them. It is possible that one of them will work, none of them will work, or both of them will work. You don't have any linkage between the two. You must check them both. So let's do that. 3 times 1/9 minus 5 times the square root of 1/9 is equal to 2. Or 1/3 minus 5/3 is equal to 2. That's not true, is it? But do you see how it's the right, wrong answer? That was only 1/3 What would be the change to make that would make it work? No. One little change you can make in this. Plus. If I made it plus 5/3, 1/3 plus 5/3 would be equal to 2. So it's the right, wrong answer. We can cross it out. Don't scribble it like this. I need to see what your thing was. Just put a little beep, beep. Thank you. Totally didn't feel that condescension there. Poor guy.
Hi, Ben. Ben, I miss you. It's a fish.
Okay, next one. Let's check the 4. 3 times 4 minus 5 times the square root of 4 is equal to 2. Is that true? Yeah. This is 12 minus 10 is equal to 2. That works. So we're going to take the 4, promote it to set notation, and circle it so you get to draw my eye to it, and I get to say, yay, you got it right. Okay. Oh, I do, yeah. Okay. Next one. 3x is equal to 2 plus x root 5. So of any of the problems that we're going to do, this is one that's going to give you the most trouble because it's not a radical problem. We're not ever going to square both sides, ever. What we are going to do when you solve linear problems is you do get the x terms by themselves, and you move all the non-x terms to the other side. It's the same thing you've always done. So let's do that. 3x minus x root 5 is equal to 2. What now? What do you mean by take out? But then we'd have an x in the denominator. Factor? If I put parentheses around this, and I take the greatest common factor of x out, I get x times 3 minus root 5 is equal to 2. I want to pause on this for just a second. What is 7x minus 4x? Why?
Because you take out the greatest common factor.
And then you take away 4x, you have 3x's left.
True. But isn't this really what you're doing? You're factoring an x out and you're just subtracting the coefficients. I mean, you guys don't truly think about it as I have 7x's minus 4x's. You think about it like, what's 7 minus 4?
Correct.
And since they're both multiplied by x, we actually use, guys, please, we use the distributive property in reverse to pull the x out. That is what is happening here. I am using the distributive property in reverse to pull the x out, to grab that, to pull and that's called factoring. We factor the greatest common factor out. And this may not be the greatest. It's just I need to take the x out. What's my next step once I have the 3 minus root 5 isolated? Now divide by x. Divide by 3 minus root 5 is a big, complete group. I get 2 over 3 minus root 5.
Are you kidding me, Kendall?
Yeah. Yes. Jay, what? Yeah, I don't know what down means, but I just know to push it up like that. Now I'm going to show this next step as x times 3 minus root 5 over 3 minus root 5 equals 2 over 3 minus root 5, because later on you want to look and see this is what we actually did and why. And so I get x is equal to 2 over 3 minus root 5, and we're going to rationalize by multiplying the denominator by 3 plus root 5. So we're going to multiply the numerator by 3 plus root 5. When you do this, it may be better to not multiply the 2 in just yet. You don't know if it's going to cancel with something in the denominator. And even if it didn't, I'd rather almost leave it factored out. Denominator is the only way that we square both sides. We get 9 minus 5. So I end up with 3 plus root 5 over 4, which is, we can cancel the 2 and the 4 to give me 2 on the bottom. And again, if you were in the olden days and you want to know what 3 plus root 5 over 2 is, it wouldn't be hard to take 2.23, add 3, and then divide by 2 and get an approximation. So that goes in set notation. That's your complete final. Yes, Mad?
Just making sure. So you would rather have us not distribute the 2 in until we get the denominator to see if it cancels out?
Yeah.
If it doesn't cancel out,
If it doesn't, you can, but I wouldn't. I'd just leave it. I really would.
So like that's simplified enough for you.
Yeah. So if you, what she's asking for is something like, let's say we factored a 3 out and I got 1 plus root 7, and I did this denominator, but then I got an 11. Do we multiply the 3 back in? Nah, I wouldn't worry about it. Okay, 6. 5 cubed root of x minus 3 equals 2. This is also a radical because we have a variable expression underneath the radical. I could divide the 5 over, but kind of why? What's my real step in dealing with the radical? Well, we don't multiply, we raise. What's the opposite of cubed rooting? Cubing. So let's take the 5 cubed root of x minus 3 equals 2 and raise the left side and the right side to the third power. I can do that because 5 cubed is 125. Cubed root of x minus 3 cubed is, and 2 cubed is, so I get 125x minus 375 is equal to 8. Or 125x is equal to 383. And so x is equal to 383 over 125, which I know won't simplify because 125 factors into 5 cubed. Why not? No, I'm kidding. What, Jay? You can, and then you're going to be left with 8 1/25ths plus 3, which is okay. You're just going to have to bring those together again. So it's the same math that you do eventually. That's why, you know, to keep avoiding being improper fractions, I'll distribute first. But either way, you're going to get the same thing. Can someone raise their hand and tell me why I didn't check that before I put it in set notation? Because I didn't. And I don't have to. Wait. Hand. I want a hand on this one. Robbie. Yeah, cube root. Cube root, 5th root, 7th root, 9th root, we don't have to check. Cube roots of negatives are negatives. Cubes, negatives cubed are negatives. It kind of preserves all that. It's similar to linear. What power is linear, by the way? 1. That's linear. X to the first. So odd powers, 1, 3, 5, 7, 9, we don't have to check. 2, 4, 6, 8, 10. We have to check those. Okay, number 7.
Wait, is this on radical or linear?
Right side. Root x plus root x plus 7 equals root 7. It's definitely radical. I mean, there's radicals everywhere.
Sounds like a book. Can you write a book called like Radicals Everywhere?
With a problem like this,
Literally just a book full of radicals. You want me to paint it?
Clean your room, Leighton.
What did you just say?
with a problem like this, I am checking your process as well as your result. So there are radicals everywhere.
It's funny. Gotta clean them up. They're everywhere.
My goal is to isolate one radical. And I would pick the most complicated one to get by itself. So let's get the root x plus 7 by itself and move everything to the right side. Root 7 minus root x. Because now we're going to square the left side and the right side. And when I square the left side, the radical drops and I get x plus 7. But I can't because then I'd have to FOIL that left side. And I'm going to have to FOIL the right side. And when I FOIL the right side, I at least have some simpler radicals to do that too. That's why I got the x plus 7 by itself. I need to do root 7 plus minus root x times root 7 minus root x. You cannot just distribute the square across addition and subtraction. So that gives me 7 minus 2 root 7x plus x plus 7 on the left. Which is fine. If I move the 2 root 7x to the left side, I get 2 root 7x is positive. If I move the x plus 7 to the right side, they cancel out and give me 0. Which is fine. Divide both sides by 2. Square both sides. And divide both sides by 7. You still get x is equal to 0. No, not for nothing. 0 is a number. It's worthy of your attention. If you plug it back in, and if we check it, we're going to check that root 0 plus root 7 plus 0 is equal to root 7. That works.
Nope.
So how can we make this more complicated?
Did you want to go over the quiz?
We do, but do you want me to not give you a problem type that you're going to have to do on homework? Yeah.
Yeah, very much. Photomath is helpful.
Yeah. Oh, I love photomath.
What's photomath? I've never seen or heard about that.
So weird.
It's just really cool.
It's just great
It's an
app
app
that
where you take
teaches you
photos.
mostly cheat
I know what
on
it
your
is.
homework assignments.
Yeah.
But it can be helpful if you don't
It's easier than
If
like
you don't
looking
know
it up
what's
though.
Then you can see what I said.
Like it scans it.
Yeah.
Like you have to look it
How
up.
does that work on tests?
It does.
It doesn't, but
It
like teaches you homework on
It does teach you how to do how to do it. If you look at it, it explains it.
Give me. I know what it does. Give me a
They
first.
also give you all the work.
Give me a first step here.
Hypothetically.
Yeah. But let's go before that. Radical. I'm spreading my work horizontally, and this is what you guys are truly going to do. I need you guys to be very good with your horizontal work. So we're going one column today. One column on your homework, and don't pre-plan your space.
Dude,
You're going to need a lot.
paper.
Get over it.
It's not a lot of paper in England.
It's an island.
Okay, we're going to isolate one radical.
Only has a certain amount of trees.
And whichever one you pick, I'm just going to move which one's going to be the easiest to get by itself. So let's keep the root 5y minus 1 on the left. And we'll add 2 plus root 7y plus 9 on the right.
Wait.
I added root 7y plus 9 to both sides. Now I'm going to take the left side and square it. And I'm going to take the right side and square it. And the left side just becomes a 5y minus 1. But the right side, in order to truly square it, it means I have to multiply it by itself. Which means I have to do first outer plus inner, 4 root 9, 7y plus 9, and then last.
Wait, why is it 4?
Yeah, why is it 4?
2 twos.
Oh, no, like, I know that, but like, I'm not stupid, okay?
That's why it's 4.
Two.
Two.
Oh, because you just add.
Add them twice.
Okay.
Okay.
Should that be absolute?
It shouldn't what?
Should that be absolute value?
It shouldn't, because y couldn't have been negative to begin with, and we're solving, so we'll take care of that when we try to get the y and see if it works. The only time, guys, please, the only time it's actually absolute value, Colin, is if I have this, root 7y plus 9 squared, square rooted, and I'm simplifying that. That's a different order. Square rooting the square is absolute value. Okay, let's simplify by moving all the non-absolute values, or sorry, non-radical stuff to the left side. I get negative 2y plus 13 minus 14 is equal to 4 root 7y plus 9. And before you square both sides a second time, we can make things just a tiny bit simpler to do in your head.
Factor of 2.
Yeah. We can make this negative y minus 7 is equal to 2 root 7y plus 9 for reasons of just dividing the left and the right side by a 2. I don't want you guys, without calculators, to have to do lots of chicken scratch in the corner with figuring out multiplication. I know 14 squared. You know 14 squared, 196, but you shouldn't have to do 14 squared if you can do 7 squared. Later. Later. Okay, now we're going to square both sides, which gives me y squared plus 14y plus 49 equals 4 times 7y plus 9. Or y squared plus 14y plus 49 is equal to 28y plus 36. Or y squared minus 14y plus 13 is equal to 0. Factor y minus 13 and y minus 1. And you get two solutions of y is equal to 13 or y is equal to 1. Now, I'm going to let some people catch up here for a second while we talk about a couple of things. This is a true Algebra 2 problem because it took multiple steps and skills to get here. You guys have to remember a lot of things. How to factor, how to distribute, how to multiply polynomials, multiply binomials. You have to solve by squaring both sides. You have to move things around. And even then, we still aren't complete with the problem because we have to check if both 13 and 1 actually work. So we're going to check the number 13. If you get numbers that don't give you clean radicals, you might want to second guess whether you actually got the original wrong or right answer correct. Check 13 means to plug 13 in for y. So I'm going to go 15 times 13 minus 1 in a radical. Or 5 minus times 13. I said it right. Or read it right. I said it wrong. 7 times 13 minus 1, getting plus 9, equals 2. So 5 13s is 65. 65 minus 1 is 64. Root 64. 7 times 13 is 91. 91 plus 9 is 100. And I get 8 minus 10 is equal to 2. It was close, which means that 13 was the wrong answer, which means the 1 is probably right too. Let's check 1. 5 times 1 minus 1, radical, minus 7 times 1 plus 9, radical, is equal to 2. Or root 4 minus root 16 is equal to 2. Or 2 minus 4 is equal to 2. 1 is out. So we've checked both, and we get to say empty set. Is there a place where you might have suspected that it could be an empty set? I'm not saying you can't truly get it here because y could have been a negative number that would have gotten that to be a positive number. You can suspect it there. Now, in this problem, you need to completely work it out and get to where you're going. I'm going to stop this for Ben.
This is Marley Adams from the class of 2021.